Hello guys, in today's video we will be taking this example from commutative algebra, which is also known as modules, and now we want to show that the square root of 2 script z plus script z by script z is isomorphic to the square root of 2 script z. Now first things first, we'll say proof. Firstly, we define an R-Isomorphism. Firstly, we define an R-Isomorphism from the square root of 2 script z to the square root of 2 script z plus script z by script z. Then we now define a mapping. Now we then define a mapping which is phi of the square root of 2 script z into the square root of 2 script z plus script z by script z, such that phi of x is equal to x plus script z. Now once we've defined this mapping, now we want to now show that phi forms an R-Isomorphism. Now we want to show that phi is an R-Isomorphism. An homomorphism. That is for any x, y, which is contained in the square root of 2 script z, where script z is the set of all integers. Now we now have that the phi of x plus y, which is equal to, we know the phi of x to be equal to x plus script z. We know the phi of x to be equal to x plus script z, and also the phi of y to be equal to y plus script z. Now we consider phi of x plus y, which will be equal to x plus script z plus y plus script z. Remember, where the script z is the set of all integers, which is equal to x plus y plus script z. If we further split this apart, x plus script z plus y plus script z, which shows that we have phi of x plus phi of y. Now also we'll say let R be contained in script z, which is the set of all integers, and x be contained in the square root of 2 script z. We have have that the phi of Rx is equal to Rx plus the script of z, script z, which is equal to, since R is a scalar, so we'll say R in bracket of x plus script z, which is equal to R phi of x. Now we can see that phi preserves addition and scalar multiplication. Then that is phi is an R module. Now, since phi is an R module, now we proceed on showing that phi is 1-to-1. We now say we also want to show that phi is 1-to-1 if phi of x is equal to phi of y. Then, which is an assumption, we are assuming that if phi of x is equal to phi of y, then we can now say that x plus the script of z is equal to y plus the script of z for all x comma y is contained in the root of 2 script z, where remember where z is the set of all integers. You can now say thus phi is injective, which also means that phi is 1-to-1. Now we proceed again by showing that phi is surjective. Now we also want to see that phi is surjective, meaning that it is onto. Now for any z plus script z such that this is contained in the root of 2 script z plus script z by script z, it follows that x is equal to z. It follows that x is equal to z. Now we will now see that this implies that the phi of x is equal to z plus script z. Now with this following assumption, we can now see that phi is onto. We can now see that phi is onto. Now, given that phi is injective and phi is surjective, now we can now see that phi is isomorphic. We can say that phi is isomorphic as required by the example. as required by the example, and therefore phi is an isomorphism. Between the root of 2 script z and the root of 2 script z plus script z by script z. Hence, by symmetry, we have that the root of 2 script z plus script z by script z is isomorphic to the root of 2 script z, and the proof is complete. Now, also remembering from abstract algebra, we know that the first law of isomorphism, or the first isomorphism theorem, states that if we have the domain of phi by the kernel of phi is isomorphic to the image of phi. This same representation also can be used to solve this problem, meaning it can also be used to show that the left hand side is isomorphic to the right hand side, where our domain of phi is given as the root of 2 script z plus script z. Our kernel of phi is given as script z, and our image of phi is given as root 2 script z. Now remember, we defined a function saying that phi is defined on root 2 into root 2 script z plus script z by script z. Now, definitely, using this expression given above from the first isomorphism theorem, we can also see that the root of 2 script z plus script z by script z is isomorphic to the image of phi, which is the root of 2 script z. And there we have it. We've been able to show that the left hand side is isomorphic to the right hand side. Thank you for watching this video, and please like and subscribe, as more videos on abstract algebra and commutative algebra and many other interesting topics in mathematics will be created. Thank you for watching.